Okay, so we are at number 4 from the lecture handout. Okay, so in number 4, we are asked to find the probability. So we are asked to find the probability that a standard normal random variable. Okay, so we have a standard normal random variable. We use g for this variable, right? So we need to find the probability that g exceeds 1.96 in absolute value. Now, how can we write this in mathematical statement? So we are asked to find the probability, right? So we use p to represent probability. So we are asked to find probability that a standard normal random variable, so which is g. So we are asked to find the probability that g exceeds 1.96. Now exceeds means greater than, less than, is greater than, right? So the normal random variable, standard normal random variable, exceeds 1.96 in absolute value. It means our standard normal random variable, this is the absolute value of standard normal random variable, exceeds 1.96. so this is what we are asked. So we are asked to find the probability that the absolute value of g exceeds 1.96. okay, now let's see. The very first step is we start from the distribution. Okay, we draw our distribution. So we have a standard normal distribution. We draw a bell-shaped curve. So what is our horizontal axis? It is a g. Okay, what do we know about the mean of this distribution? Mu is 0. Okay, so our mu is 0. Now here we have the probability of absolute value of g. Now how do we get rid of this absolute value of g, or how can we rewrite this? So how can we rewrite this? Okay, now what does this mean by absolute value of g greater than 1.96? How do we rewrite this? How can we rewrite this inequality without using absolute sign? So this is an inequality, absolute value inequality, and we need to rewrite this without absolute value sign. And this is same as, okay, so this is same as g greater than 1.96 or g less than negative 1.96. So we have absolute value inequality, okay, and we can rewrite this absolute value inequality without using absolute value sign, and that will be g is greater than 1.96 or g is less than negative 1.96. If you have absolute value of g less than 1.96, how do we rewrite this without using absolute value sign? So this is g is greater than negative 1.96 and less than positive 1.96. okay, so if you have greater than, so you have an absolute value. If your absolute value inequality has a greater than, this is what you're going to write down. Okay, you can rewrite without using absolute value sign. And if you have less than, this is how we rewrite without using absolute value sign. Okay, so let me rewrite what we are asked to find. So we are asked to find probability that g is greater than 1.96 or g is less than negative 1.96. Does anyone have any question up to here? Now here we have a OR. Now what does it mean here? How do we find the probability of G greater than 1.96 or G less than 1.96? OR is union, right? So this is probability of G greater than 1.96 plus probability that G is less than negative 1.96. Now let's have an area stated for this two probability. Now we have positive 1.96. Let's say we have positive 1.96 here and negative 1.96 here. Okay, so probability of G greater than 1.96 means, so what is the region? So this is from positive 1.96 to all the way to the right. So we are interested in finding this area. Okay, and the next we have probability that G is less than negative 1.96. So less than negative 1.96 means this area. So we need to find the area of these two shaded region. Okay, if we can find, we have our probability. Okay, now let's start with the green region. How can we find the area of green region here? What do we know about the area, total area on the right of 0? So what do we know about the total area on the right of 0? It is 0.5, right? From 0.5, if we can find this area, and subtract from 0.5, we get the area of green region. Do you all agree? We find the area of that orange, subtract from 0.5, and we can find the area of green region. Okay, now what about the area of this region? How do we find the area? What do we have? G table, right, or normal table. Okay, now I want you to use the normal table. So we have 1.96, so 1.9 and 6, so that is 0.4750. Do you all find that 0.4750? 0.4750. Okay, so if that is the case, what will be the area of green region? That is 0. Okay, now let me write 0.5 minus 0.4750. This is the probability for green region. Plus, now what about for the blue region? What do we know about the area of this white region? What is this area? Isn't that same as 0.4750? Do you all agree? The white area and the orange area, they have a same area, right? So the area is 0.4750. So the blue region, the area of the blue region would be, that is 0.5 minus 0.4750. Okay, and this is 0.0250 plus 0.0250, and we have 0.05. So this is the probability that absolute value of G exceeds 1.96. Does anyone have any question here? Okay, now let's go to the next one. Okay, the next here we have, now if we have our normal distribution And every time, keep in mind that we can use our G table only when we have standard normal distribution, okay? If you have a normal distribution, we can't use this G table. We must have a standard normal distribution, okay? So now if we are given a normal distribution, then we can convert that normal distribution to a standard normal distribution, okay? So let's consider we have x as a normal random variable. That normal random variable has a mean mu, standard deviation sigma. Then the same random variable, we can rewrite that in terms of a standard normal distribution, okay? Our G is equals to x minus mu divided by sigma. So this is how we can convert our normal random variable into standard normal random variable. And every time, if you have a normal distribution, if you are asked to find the probability, then we have to convert that given normal distribution into a standard normal distribution. Okay, now till now, like in every examples we did, we had G as our random variable, so we didn't convert. Okay, now here we will see an example where we have to convert our normal random variable x into a G, and this is how we convert. Okay. Okay, now let's go to this example. Assume that the length of time x, so we have a x as a length of time between charges of a cellular phone is normally distributed. Okay, so we have x, which is the length of time, and this length of time is normally distributed with a mean of 10 hours and a standard deviation 1.5 hours. So our mean is mu is 10 hour, standard deviation is 1.5 hours. Find the probability. Okay, so we are finding the probability that the cell phone will last between 8 and 12 hours between charges. Now, how do we write this in mathematical statement? How can we rewrite this? So here we need to, so we are asked to find the probability. So we have a P that the cell phone will last between 8 and 12 hours. Now, how do we write down this? So we have x as a length of time, right? So the x has to be in between 8 and 12, means x has to be greater than 8 and less than 12. So this is what we are asked to find. So our x is the length of time that is normally distributed. Okay, so since this is normally distributed, so we can draw distribution for this variable. Okay, now what will be our horizontal axis here? X, that's good. So we have x here. Okay, now at the center we have the mean. What is the mean? Is it 0? No, right? This is not, our x is not a standard normal variable. So our x, the mean is given as 10. So our mean is 10. Standard deviation is given as 1.5. Okay. And we are asked to find the probability that x is in between 8 and 12. Now let's locate 8 and 12. So we have 8, let's say somewhere here, and 12 somewhere here. Finding probability means finding the area, right? Now, can you say the area we are interested in here? So we are asked to find the probability that x is greater than 8 and less than 12. Now, where is that area for this probability? So everything between 8 and 12, right? So let's draw a vertical line at 8 and let's draw a vertical line at 12. Okay? So we are interested in finding the area in between 8 and 12. It means we are interested in finding area of this shaded region. Okay, so let me call the area on the right of 10 as a A1 and on the left as a A2. Okay. Now, can we use a normal table here? we can't use. Normal table is only for g variable. Okay, we have a x variable, but we know how to convert x variable into g. So let's convert every x variable into g. Now we have 8. How do we convert 8 into g? So the formula is x minus mu divided by sigma. Our x is 8. So 8 minus mu is 10 divided by sigma, 1.5. Can you give me the final answer here? Negative 1.33. Okay, now let's find g for 10. So 10 minus mu is 10, which is given to us, divided by 1.5 is standard deviation, which is given to us, and that is 0. For 12, that is x is 12 minus mu 10 divided by 1.5, which is positive 1.33. And this is our we can draw a horizontal line here so that so this is our g. Okay, so we have negative 1.33 here, 0 here, positive 1.3 here. Okay, any question up to here? Now instead of 8, now we can replace our 8 is same as negative 1.33. Okay, so let me write. So we are asked to find probability that x is greater than 8 and less than 12. Now can we rewrite this as a probability that our g is greater than negative 1.33 and less than 1.33? Do you all agree here? Because see, 8 is same as negative 1.33, 12 is same as positive 1.33. Okay, and make sure to change the variable from x to g. Okay, so from x to g. So we are rewriting our x in terms of a standard normal variable. Okay, now so how do we find this area? So this probability is area A1 plus area A2. Do you all agree here? Okay, now, and these two are equal, right? Area A1 and area A2 has to be same, right? Now can I rewrite this as a 2 times area A2? Do you all agree? Okay, now what about A2? How do we find A2? A2 is probability that our g is greater than 0 and less than 1.33. Okay, so this is 2 times, and what is this probability from the g table? 0.4882. 4082. Okay, thank you. 4082, and the final answer is 0.8164. This is the probability that the time is in between 8 and 12. Okay, so you have a normal distribution, then you are using z table. Okay, but make sure to convert your x into g, and the remaining is same. Okay, like whatever we did in our last class. Do you have any question? Okay, now let's see what we have next. Okay, now these are the general steps. Okay, as I said, you always start from drawing a distribution. Okay, start to draw a normal distribution. Okay, these are the general methods. You indicate the mean of our variable. Okay, then you set the area corresponding to the probability you want to find. Then we convert our x values into g value using this formula. Okay, then we use our table 2, or we use our normal table. So every time if you have the normal distribution, you have to have the distribution, you have to have a picture. Okay, then you set the area, you convert x into g. If you don't have g, then you have to convert. Okay, then at the end we use the table. Okay, now So here we have the next example. Suppose an automobile manufacturer introduces a new model that has an advertised mean in-city mileage of 27 miles per gallon. Okay, so this is the mean here. So we have a mean 27 miles per gallon. Although such advertisements seldom report any measure of variability, suppose you write to the manufacturer for the details of the test and you find that the standard deviation is 3. So we have the standard deviation is 3 miles per gallon. So our mean mu is 27, standard deviation is 3. This information leads you to formulate a probability model for the random variable of x. The x is the in-city mileage. Okay, our x is the in-city mileage for this car model. Okay, this is how we define our x to be in-city mileage. You believe that the probability distribution of x can be approximated by normal distribution. Now the probability distribution of x is normal distribution with a mean of 27 and a standard deviation of 3. Okay, so let's start. So it's a normal distribution. So let's draw a bell-shaped curve here. Okay. Our horizontal axis is x. Okay. We have a mean which is 27. Now let's see what we are asked to find here. Okay. Now the question for us is, what is the probability? Okay, what is the probability that x is less than 20? So this is the question for us. Now I want you to try this one. Okay, so we have the mean equals to 27, sigma is equals to 3. Okay, we already have the graph here, we already have the normal distribution. Now what is the second step? We set the area. Okay, so we are asked to find probability that x is less than 20. So I want you to set the area here, okay, for this probability. So set the area, okay, and that area is probability that x takes a value less than 20. Okay, that's good. Less than 20. So okay, less than 20. Okay, that's good. So once you have shaded region, you convert every x into g. Okay, less than 20 looks good. Which is less than 20? Okay, I want you to say the area for this one. So you locate 20. Where do you find 20? So your 27 is here, right? So where will be 20? Okay. And x less than 20 means, where do you find less than 20? Yes. So you draw vertical line at 20. Okay. Good. So if you have finished setting the area, so you need to set. No, that might be correct. Okay, I'm not checking final answer now. So you set the area. Which one is the area here we are interested in? No. X less than 20. So where's your 20?
This way. Okay.
Yes. So I want you to say that. This color. And once you have set the area, you convert every x into g. Okay. Okay. Now you convert all this x value into g. Okay. You need to say, color it. Where is x less than 20? Yes. Yes. Say color it. Yes. Good. Okay. Now convert every x into g. Okay. So you convert x into g. So you all have this. So let's say 20 is somewhere here. Less than 20 means everything on the left of 20. So this is less than 20. Now I want you to convert each x value into g. So for 20, how do we convert? 20 minus mu, 27 divided by standard deviation 3. What do we have final answer? Negative 2.33. Okay. 33. So this is negative 2.33. And how do we convert 27? 27 minus 27 divided by 3, and this is 0. This is 0. Okay. So let's call this is A1. We can call this A2. Now how do we find this probability? So probability that x is less than 20. Is it, can I rewrite this as a, okay, this is A1, but how do we find A1 here? To find A1, we need to find A2, right? Okay, now how do we find A2? So let me draw area A2 on the right. So this is positive 2.33. Area A2 and area A3 is equals to each other. Do you all agree? Right? Now how we can find area A3 from the normal table, right? So what is that area A3 equals to? 2.33. So 0.4901. That's right. 0.4901. So this is area A3. So area A2 will be also same. 0.4901. Now what will be our area A1? That is 0.5 minus 0.4901. And what do we have for this? 0.0099. Okay, 99. So this is the probability that x takes a value less than 20. Okay. So at least I want the graph. Okay, you don't need to show detail work. Okay, but make sure to set the area. Okay, and if you can use like A1, A2, A3, then it would be very helpful for me. Okay, so this is what we have. Now let's go to the, okay, any question on this one? All right, now let's see what we have next. Okay, in number 2 or next example, we are asked to find the value of g. Okay, let's call it g naught. So we are asked to find g naught in the standard normal distribution that will be exceeded only 10% of time. That is, find g naught such that p of g greater than or equals to g naught is 0.10. Now let's start with our picture. So let's draw a standard normal distribution. So we have a standard normal distribution. So it means we have a g here. Okay. So if we are talking about g, what do we know about the mean? It is always 0. Okay. So we need to find g naught. Okay, such that the probability that g greater than or equals to g naught is 0.10. Now where will be our g naught? We don't know it's positive or negative. Okay, so our g naught can be on the left of 0 or on the right of 0. So we have to locate g naught here. Where do we think g naught will be? G naught is any number. Okay, we don't know it is positive or negative 8. So where do you want to put g naught? On the left of 0 or right of 0? What do you think? So let's see if we have something. Okay, now let's call our g naught is on the left. Okay, not sure. Now let's check. So what do we know about the probability that g being greater than g naught is, which is 0.10, right? It means the area on the right of g naught is 0.1. Does this make sense here? So if we have g naught on the left and it's given that the total area on the left of g naught is 0.1. Do you all agree with this? We know, what do we know about this area? The total area on this part is, we already know this is 0.5, right? But we can't have this part and this part 0.1. It has to be greater than 0.5 at least. Okay, so our g naught is not on the left of 0. So it should be on the right. Okay, so let's say, we don't know where, but let's call somewhere here. G naught is here. Okay, and the area on the left of g naught, or the probability. It's the same thing, okay? Do not get confused. Area probability is the same thing here. So this area on the left of G naught is 0.1. So this is what we are given to us. Our target is finding G naught. Okay. Now what do we know about this area of this green region? How do we find the area of this green region? The total area on the right of 0 is 0.5, right? Yellow region is 0.1. So the remaining would be green, right? Which is 0.4. Okay, 0.4. Our target is finding G naught. Now we have a G table. Now in the G table, so this 0.4, so I want you to look for the number which is close to 0.4 and the corresponding G value would be G naught. So look at the probability or the area closest to 0.4, okay? So closest to 0.4. So 0.4. Did you find the closest to 0.4? What is that probability closest to 0.4? Okay, 0.3997. Okay, what about 0.4015? That is like that's 15 away, right? And that is 3 below. So 0.3997 is the closest. Do you all agree? And what is the corresponding G value for that probability? That is 1.28, and that is our G naught. So G naught is 1.28. So this is 1.28. So this is the work you have to show, okay? You draw the picture, you set the area, and you have the final answer, 1.28. Good. Can we start next? Okay. The next here, we are asked to find the G naught such that 95% of the standard normal G values lies in between negative G naught and positive G naught. That is find G naught such that the probability that G greater than negative G naught and less than G naught is 0.95. Now let's draw the picture here. So we are talking about standard normal distribution. So we have a G here, okay? We have a mean 0, negative G naught, let's say this is negative G naught, positive G naught. Now can you locate what that 0.95? Which part is 0.95 here? So everything between negative G naught and positive G naught, right? So from negative G naught to positive G naught, this is 0.95. So this is 0.95. Okay, so if that is the case, what do we know about the area on the right here, right of 0? Yes, half of 0.95, right? And what is the half of 0.9? 0.475. Our target is finding this G naught. So now you use a G table, okay? Look for the number closest to 0.4750. 4750.
1.96.
Okay, before that, what is the closest number? Give me the closest number. 47.
750.
How much? 47?
It's
Exactly. Okay, so yes, okay, exactly we have. Okay, this is very rare. We won't have every time like this. Okay, so the corresponding G value is 1.96. So G naught is 1.96. Good. Okay. Now the next here we have, suppose the scores X on a college entrance examination is normally distributed. So we have X and that X is normally distributed. So let's start with a bell-shaped curve. So we have a bell-shaped curve here and it is normally distributed. Our X is the variable, right? With a mean of 550. So our mu is 550. So this is at the center, right? So 550 is here. Standard deviation is 100. Standard deviation is 100. A certain prestigious university consider for admission only those applicants whose scores exceeds the 90th percentile of the distribution. Okay. So if your score exceeds the 90th percentile of the distribution, then you get the admission. Find the minimum score an applicant must achieve in order to receive the consideration for admission to the university. Okay, now what does it mean by 90th percentile? So let's so for example, your score is let's call it X. Okay, we don't know what is that score, so let me call your score is X. And what does it mean by this X is at 90th percentile? So your X, so 90% of the students. So if X is at the 90th percentile, then
It would look like number 2.
so we are looking for the minimum score, right? That has minimum score for the admission, okay? And we know our X, okay, let's consider our X is the minimum score, okay? So let's call this is our minimum score. Okay, let me call X naught. We already have X here, so let me call X naught, okay? So that you won't confuse with X. So let's call X naught as a minimum score, okay, that you need to get admission here. And we know our X is at 9, our minimum score has to be at 90th percentile. What does that mean? If X naught is at 90th percentile means 90% of the score is it below X naught or above X naught? Our X naught is at 90th percentile means the 90% of the score is below X naught, okay? So let's say our X naught is somewhere here, okay? So the 90%. So from X naught below means everything on the left of X naught, right? So this is 90%. So 90%, or let me just write 0.9. Okay, the total area is 0.9. Is it okay if I use X naught on the left of 550? So for example, like how do we know X naught is on the right of 550? What if we have X naught here? Does this 0.9 make sense here? No, right? Okay, so X naught has to be on the right of 550. Okay, so our target is finding X naught here. Okay, so what do we know about, okay, this area, the area from on the right of 550. So what do we know about this area? That's the 0.9 minus 0.5, right? Do you all agree? So from here to X naught is 0.9. This yellow region is 0.5 and the remaining 0.4 would be the area of green region. Do you all agree up to here? Now we have a X and we don't want X. We need to convert X into G, right? Now let's convert every X into G. So for 550, how do we convert? 550 minus mean 550 divided by standard deviation 100, which is 0. What about X naught? How do we convert X naught into G? That is X naught minus 550 divided by 100. Do you all agree? So we are converting every x into g. Okay. So to convert your x value minus mean divided by standard deviation. So our x value is x naught here. Okay. So x naught minus mean divided by 100. Okay. Now, so this is the g value for x naught. This is the g value for x naught, right? Now, can we find g value for x naught, since we know the area is 0.4 from 0 to this x naught? So let me call this as a g naught. Okay. Now, is there any way we could find g naught from the normal table? So look at the number closest to 0.4. I think we already did that.
Yeah, it's 1.28, isn't it?
So from our previous example, okay, so from our example 2, we already know 1.28, right? So our g naught is 1.28. 1.28. Now we have an equation here, x naught minus 550 divided 100 equals to 1.28. We have this equation, so let's multiply both sides by 100. This 100 cancel. We have x minus 550 equals to 128. We add 550 on both sides, and x, this is gone, equals to 678. Sorry, x naught. So the minimum score has to be 678 to get an admission. Okay. I think we are done with the handout now. Let's go back to our activity handout. Does anyone have any question here? Okay. Okay, now let's start with the activity. Page 1 and 2. Does anyone have any question on page 1 and 2? Okay. Now we have page 3 and page 4. And in number 3 we are asked to find the g naught, and on the x we are asked to find the probability. Okay, is it okay if I start the activity? Does anyone have any question on this part? Okay. So let me start. Okay, let me do number A at first. Okay, so we have A, and for each problem I want you to draw the picture here. Okay, so what kind of distribution is this? This is a standard normal distribution, right? So let's draw a standard normal distribution. Our variable is g. Okay, we are asked to find g naught for this page 3. Okay, such that probability that g less than equals to g naught. So we have a 0 here, mean 0. Now where will be our g naught? The total probability that g is less than g naught is 0.401. Now where is that g naught? On the left of 0 or on the right of 0? Can we have g naught here? So if, for example, if you take your g naught here, and less than 0 means everything on the left of g naught. Now is this probability close to 0.401? It will be greater than 0.5, right? So our g naught is not on the left. So it's not on the right, it has to be on the left. So let's call our g naught is somewhere here, g naught, and the area, so this is area. Okay, this probability is same as area, so the area on the left of g naught, so from here, so this area is given to us as 0.401. Okay, And you can answer this on the graph. Okay, what do we know about this area? What is this area will be equals to? That is 0.5 minus 0.401, right? And what is that difference? 0.5 minus 0.401. Zero 0.5 minus 0.401. 0.0 or
Because that up there is 0.0401.
oh, okay, thank you. So this is 0.0. Okay, so the difference is 0.99.
4599.
Okay. So if I take the same area on the right side, so this G naught on the left should be negative, right? So let me call this is negative, this is positive G naught. And what will be this area? Same as 0.4599, right? Now the next step is we use our G table and we look the number closest to 0.4599. Okay, 0.4599. Oh, we have exactly that value, right? That's what I see. Did you find 0.4599 on the G table? And what is the corresponding G value? That is 1.75. So our G naught is 1.75. Okay. Now this G naught is on the left means that is negative 1.75. Okay, now I want you to try the remaining, okay? And I'll be helping you. We still have like 2 more minutes. At least, okay, I think you can complete at least B.